Hi MVC, so part 2 of Monday coming at you here. So hopefully you watched the first video where we defined curl F. For now, curl F is just going to be the function curl F, which is defined to be div cross F, and del cross F. And so when we get later in chapter 15, curl will actually have a physical definition. It's sort of an object's tendency to rotate, to curl around something. But the last section in 15.1 is our last function. And we have a vector field, f of x, y, z is a vector field. And we can find curl f, which is del cross f. This is a vector. If curl f is the zero vector at every point, then the field is conservative. And our last field, or our last function that we're going to define, is called divF. And divF is, instead of del cross f, this is going to be del dot f. What do we know about a dot product? It's not going to be a vector, it's going to be a scalar. So if I have a two-dimensional vector field, I have I hat plus nj hat, then div f is just going to be the partial derivative. So if I'm going to dot the partial derivative of x with m, that'll give me the partial derivative of m with respect to x plus the partial derivative of n with respect to y. If I have a 3D vector field, m, n, and p, then div f, again, which is del dot f. So the derivative with respect to x component goes with m, y goes with n, z goes with p. I get the partial of m with respect to x plus the partial of n with respect to y plus the partial of p with respect to z. So if I give you an example, let's say that I have a vector field in 3 space. It's going to be xy squared zi hat plus 3xy j hat plus xy k hat. I want to find div f as a function. Again, I'm just going to take my partial with respect to x, so I get 1 y squared z plus my derivative with respect to y, 3x, plus my derivative with respect to z, which is 0. Div f itself is a function. It's not a vector valued function, but I can find div f at everyone's favorite point. This will give me 4 times 3 plus 3 times 1, which is 15. So again, div f is a scalar, but it's also a scalar function. So the last thing I want to show you today is a combination of these two functions. So if I have a function, a vector field, f of x, y, z, which is mi hat plus nj hat plus pk hat, this is a vector field. And as long as m, n, and p are differentiable, then I have curl f, which is, I think we found it on the last video. I get the partial of p with respect to y minus the partial of n with respect to z. I'm trying to do this in my head. I hat minus my partial of p with respect to x minus my partial with m with respect to z j hat plus the partial of n with respect to x minus my partial of m with respect to y, k hat. So now, what if I want to find div of curl f? So this is going to be, now I want to take my I hat component and I want to take the derivative with respect to x. So this is going to be the derivative with respect to x of the partial of p with respect to y minus the partial of n with respect to z. Then I'm going to take the derivative with respect to y. So minus the partial with respect to y of the partial with respect to x minus the partial with respect to z, plus, now I'm going to take the derivative with respect to z, so the partial with respect to z of the partial with respect to x minus the partial with respect to y. So just doing the calculus on this piece, I get the derivative. Now remember, the notation for this is I get the partial of p with respect to x and then y. So this preserves the order. So this is going to be the derivative again of dx dy minus the partial with respect to n again of dx dz minus the partial with respect to p again of y of x minus minus turns into plus of dy dz plus the partial of the partial, so the second of dz dx minus the second of m of dz dy. Now I know that mixed partials can be in any order, but I can see that these cancel out, and these cancel out, and these cancel out. So no matter what my function is, the divergence of the curl of a function is 0. So we say the div of curl f is 0. Again, we're going to give you a physical interpretation of what div is and what curl is later in chapter 15, but those are not actually the definitions of the function. So these are the tools you're going to need to finish your homework in section 15.1. There's also an example in your book and that you can read through. So good luck with that, and I will see you all later this week.